你就放这个。其实你那里够。这还有点。这讲不够的话，你下一集再补。你可以先忙你的 ，OK。Okay, welcome to the machine vision class. I see some of the international students here, and I'm supposed you speak no Chinese, right? Okay, so throughout the whole semester, this class will be conducted in English. Okay, it is necessary. I might summarize in Chinese, but basically, okay. I will speak mostly in English. Okay, machine vision. I will talk about the theory, okay, about machine vision or computer vision, but with the focus on industrial application, okay, especially for inspection in manufacturing, because we are industrial engineers, okay, after all. So more or less, I will focus more on manufacturing application, which means I won't say anything about face recognition. I won't say anything about OCR, optical character recognition. I won't say anything about autopilot, car autopilot, okay? But the basic theory and the algorithm can be applied in the field such as I just mentioned, face recognition, or in any other field, with the focus, okay, for manufacturing application. I would separate the topic into two parts. One is the traditional machine vision, and the other part will be the deep learning. Okay, but with the focus on computer vision, okay, which means I won't say anything about natural language processing. Okay. Well, actually, you might think, why don't we just focus on deep learning for computer vision? However, as you know, the so-called deep learning algorithm or deep learning model is kinds of data hungry, okay? It's a data hungry approach, which means what? To apply the deep learning algorithm, you need a lot of training samples. Without the training sample, almost there's no way you can apply the deep learning algorithm to your application. Although there's some new developed algorithm called one-shot or few-shot, okay, or semi-supervised learning, but basically everything relies on data. Okay. For example, for Tesla's autopilot system, their original version, they need to hire more than 1,000 personnel to do the labeling job. Okay, so it actually is very quite manual intensive. Okay, but with the traditional machine vision, basically you don't need any training sample at all. Okay, no training sample. Of course, you need the training, not the training sample, but you do need the sample to test your algorithm or your major or anything you develop. But basically, for the traditional machine vision, we don't need any training sample at all. Not like the different. It highly depends on the data that you collect, and highly depends on how you label or annotate the images. Okay, so we need to combine both. Okay, later on I will talk about what I'm going to include or the topic that we are going to learn. Okay, for machine vision and for deep learning. Okay, so the first half before the midterm. Okay, we will focus on the traditional machine vision. And after the midterm, then we are shifted to deep learning algorithms. Okay? And focus on the models that can be applied for computer vision. So nothing for natural language. I won't say anything about how the ChatGPT developed. Okay, nothing to do with the natural language. So you must keep that in mind. Okay, what you are going to learn is everything is about computer vision. Okay, so these two references. Okay, you don't need to buy it. Okay, you don't need to. I will show you where to download the courseware. Okay, you will have the electronic file. Okay, all the required material for the class. But I highly recommend it because throughout the reference you can have the free ebook. Okay, to download. Although it's not up-to-date textbook, but it almost the Bible. Okay, it's the Bible for the computer vision community. Okay, called digital image processing. We will talk about all the basic computer vision technique you need to know. Okay, and the other one is for the deep learning. Okay. About the deep learning. All the electronic files are available. You don't need to buy them. Okay, but keep it just for reference. Okay, just for reference. So what I'm going to do is let me say something about the deep learning first. Okay, because it dominates almost every single computer vision algorithm for every application. When we talk about the traditional machine vision, people might say, oh, it's out of date. Why we need to learn that? Okay, I will show you why we need to do that. Besides, as I just mentioned, it does not rely on the data for the trend. Okay. For a deep learning model, it's so-called end-to-end model from the input end and the output. So that's one one thing is data hungry. Is basically you need to provide the input X. Okay, and also you have to provide the output Y. Okay, for output Y, this could be for classification application. Okay, after the overlay for application, or can be applied, for example, for object detection. Or for segmentation, and a whole lot more applications. Okay. So for the user, when you want to apply the deep learning model or algorithm for your task, you need to provide the input X and the corresponding output Y, which means you need to provide the level. Okay, you need to provide the level. For example, you want to use the deep learning model to identify a person as a male or female, for example. Then you need to collect a lot of pictures, okay? And label it as a male, this is a male picture, or female. You need to do the annotation. For segmentation, you need to go for, this is so-called, as I just mentioned, you want to identify the picture, okay, a person as a male or female, the so-called sample-wise level. Okay, you have a picture, that is a sample. But if you want to do the segmentation, you have the image. You want to know where is the person. Then you need to do what? The so-called pixel-wise. You need to do the pixel-wise annotation. Okay? For the user. Which means what? You need to identify every single pixel that belongs to, for example, for the autopilot application, you need to know where is the pedestrian on the street. In that case, you need to do the labeling pixel by pixel, which is very tedious and tiresome. Okay, but that's the way to go. That's why I'm in the very beginning for the taskless autopilot. They need to hire more than 1,000 personnel to do the labeling job. Okay, otherwise there's no way you can train the deep learning model to learn. Whenever you see a picture, then you can predict the output, no matter for classification, okay, for object detection, for segmentation, or for any application. Okay, so basically you need to do the labeling work. Okay, no matter the sample base. For sample base, it's rather simple, but for the pixel-wise annotation is very, very tedious. Okay, very tedious. But that's how deep learning goes. Once you prepare the data set for learning, then you can just simply use the existing deep learning model to learn, right? There's a lot of free source that you can download. That's another reason why the deep learning can be spread so fastly, okay? Especially in the computer vision field, because most of the algorithms are free, okay? They are free. Okay. But why we need to learn the machine vision before we talk about the deep learning. That is training of the model. Training of a good deep learning model depends on the good input, okay, and the reliable output. Okay, so to make sure your deep learning model can learn everything you provide, usually we can do something like this. Before the input, given the input X, okay, the observed image X, you can do some pre-processing, the so-called pre-processing. OK， 中文比较清楚。Pre-processing. For example, if the image you capture is a very low contrast, okay, very low contrast. So you might see something, there's something wrong here, but it's hardly visible. So what you can do is you might do the enhancement. Okay, you can enhance the image, or you can do the sharpening. Okay, you can do the enhancement. 可以做影像强化。Okay， 这个叫影像锐化。You can do the sharpening, or if the input contain a lot of noise, then you can denoise first. Okay, you can do the denoise first, or do the smoothing. Okay, or even when you let's go back to the Tesla autopilot example. The picture could be taken during the day, or the picture could be taken in the night. Then the lighting will be quite different, right? Especially in the shiny day, or crowded day, or raining day. Everything, all the environment could be different. So in that case, to train a reliable deep learning model, you need to provide all possible combination of X and assign the expected output Y. You know what I'm saying? You need to prepare. You cannot just train the picture during the day. Then you have to test it, the image in the night. That would not be possible. Okay? You will fail eventually. So, before we apply the deep learning, we can do some the so-called pre-processing, as I just mentioned. You can enhance the image, you can sharpen the image, or you can denoise the image, or you can do some illumination. Normalization. Okay? 比如说我们可以把光源把它正规化，就是晚上看起来像白天。Okay? So we can make the line look like the day with some pre-processing work. So in that case, you don't need to collect all the input in every possible environment. Okay? That's one of the purpose why we still need to apply the traditional machine vision algorithm as a pre-processing before we input X to the deep learning, so that we can make the data collection much easier. We can make the training model more reliable with the help of the processing algorithm. Okay? Now, the other reason, once you get the output Y, especially for segmentation, 这个叫影像分割，等一下会谈啊。segmentation, the output from the deep learning may not be perfect. Okay, it may still contain a lot of noise. The result may not be satisfied for your final application. So in that case, then we can go for post-processing. Okay? Okay. Now, and in that case, we may still have to apply the traditional machine vision or computer vision algorithm. One more time, could be the post-processing. We can use the denoise, okay? Denoise or smoothing. Now, so the denoise or smoothing can be used as a pre-processing for the input image X, or it can apply as a post-processing for the output Y from the deep learning model. But they still rely on the traditional machine vision. Or another very important is the so-called morphology, okay? Especially for this one, okay? I will talk about this one, but let me just give you an example first. When you input X, you might have the output like this, okay? Suppose this could be the segmentation result, okay? Of for example, of a steel bone. There you come to, okay? The input X. The input X here could be a steel bone. But when the lighting, okay, emanates on the surface of the steel bone, you will see the refraction, right? The light refraction. 就是你把投射在钢珠嘛，钢珠会反射 right? So when you do some segmentation, we divide the steel bone with respect to the background, but the lighting location will become a pure white background, but this is not part of becomes not a part of the steel bone. So with the morphology, you can fill, okay, we can fill the hole. Or we might have some small minor noise, and we can apply the morphology to remove, okay? So initially, you might see this refraction, okay, on the surface of the cement steel bone. So after that, maybe we can divide it into, okay, a complete steel bone and without noise, okay, without noise. So for this application, you can better measure the dimension of the bone, or you can do a lot of inspection work here. Okay, that's the purpose. Let's talk about the morphology in Chinese. 叫形态学. Okay. Of course, morphology can be also applied as a pre-processing, but it's a very important technique. Okay, even everything is based on the deep learning. You still need to learn some of the basic, okay, the basic algorithm that can help you do better deep learning job, okay, for pre-processing or for post-processing. 所以重 就是你们现在大家都用深度学习，可是有一些事情前处理后处理，这个不是深度学习做得到。Okay, so that's one of the reasons why we need to learn the machine vision. The other reason is, as I mentioned, because for the deep learning, you need a lot of manual annotation work, okay? But with the machine learning, we can use the traditional machine learning to do the labeling, especially for the annotation work. Okay, you can use it to annotate. For example, I just mentioned you want to annotate the pedestrian on the street. Well, actually, we can identify the pedestrian or the person in the image by using a traditional method. Of course, it could be quite slow, but it's okay because we can do the annotation offline. 我们可以离线作业 so that we can reduce the implementation of the human being, so that, which means we can apply the traditional machine vision to do the automatic labeling and annotation with the annotated image, then we can apply it as the output Y. So in that case, we don't need any human intervention, okay, for the work. So the traditional way is for pre-processing, post-processing, or even we can apply it for automatic labeling or annotation. It could be very slow, okay? It could be very slow, but that'll be fine because most of the annotation or labeling work can be done, okay, offline. 它可以离线作业，所以慢一点没关系。But at least there's no inventation of the human being. Okay, that's the purpose. Okay, now let me talk about what I'm going to include, what the topics you are going to learn for the traditional machine vision, and what the topic I'm going to discuss with you for the deep learning. Okay. But actually, this course should be separated into 2 semesters. One for traditional machine vision, the other one for deep learning. Okay, but we don't have that much of time. So I try to combine the traditional algorithm and the deep learning algorithm into one single semester. It is almost mission impossible, okay, to finish every topic in one semester. So after today, every week you will see me introduce the topic in a rush because I want to make sure you will learn everything. I think that is important for this class, okay? But try do your study, okay? Do your study, okay? For every lecture after my presentation, try to learn something, okay, from you. As I just mentioned in the very first part of this semester, I will talk about the traditional machine vision, and after the midterm, I will talk about the deep learning, but basically no written exam, okay? Basically, I don't like written exam. 没有笔试，基本上没有笔试 ，OK？ But you should have, or you will have, around 5, no more than 6 assignments, okay? Homework. 会有5到6个。Whenever I finish one important topic, I will give you an assignment. And in that case, you need to have to write your own programming code. But don't worry about it, okay? I have a TA, okay? Okay, Carlos will be the TA for the class. Okay, before I talk about, I'm sorry.
Yeah, you first mentioned about we will finish everything in the first semester. So how will we do in the second semester? Because I thought that we have the two semester, right?
Oh, because the
What do you,
okay. Since you mentioned that, okay. Basically, the second semester, you can consider that because in the next semester, I will offer another course called data pattern recognition. Okay, called data pattern recognition. Since you mentioned that, okay. Let me say something about what I'm going to include for the second semester. But basically, it's nothing to do with the computer vision. Okay, but that's the. Here we have the X. Okay, we have the X, the input. Now, if you think of it, could be the image, right? Could be the image for this class. So the traditional way for computer vision is given the original image X. You need to do feature extraction. Okay? You need to extract the features or attributes. There's a lot of different names, but in this field, we prefer to use the feature, okay? Just the example I just mentioned, you want to recognize a picture, there's a male or female in the picture, then the traditional way is what? You need to identify some features. So name one, that can help you to recognize a male or female.
like the hair or something like
Right,
that?
good. Okay, you can see the length or the style of the hair, right?
Yeah.
Right, then you might have a good guess, right? But one single feature may not be good enough, right?
Right.
For the recognition, so that you might look for some other features. For example, for the skin condition, okay? Then suppose the female will be much more smooth, right? Just suppose, no bias. But anyway, that's the traditional way. Given the image, you need to do a lot of work. That's the traditional machine vision do. Okay? That's the traditional. And then once you have the feature, okay? Once you have the feature, let me put it as feature 1, feature 2, up to feature 3. Now, you convert an image into the representation of the feature. And then what? Then we go for a classifier. Okay? Then we go for the classifier. That's a high level. That's a decision for decision map. Okay? Based on the feature it extracted from the original image. Then we do. Then the most famous one for the traditional classifier could be SVM, right? Support vector machine or what? Random forest. And so on and so forth. Okay, so for the second part, or should I say the content of next semester, I will talk about this part. Okay, I will talk about more on this part, with traditional machine learning and the deep learning. Okay, for the next semester. again, because we are industrial engineering for the class in next semester, somehow I will focus more on time series data or signal, okay? But for this semester, I purely will focus on images, just image. But next semester, I will focus on the time series data, such as manufacturing process data, or the vital sign data, the heartbeat rate, for example, for the vital sign, and apply for the medical applications. That was something I will focus more. Well, actually, the topic next semester in our computer vision field, actually, we call it pattern recognition. Before the buzzword called machine learning. Actually, in the early days, we don't use the term machine learning. Okay, but now is for the artificial intelligence or even for deep learning is so popular. Now everybody seems to forget the word. Actually, that's something I prefer because everything has its own pattern. Okay, everything, not just for imaging, not just for the time series data, even for the human behavior. Okay, the human behavior. The way you talk, the way you walk, the way you consume, or the way you buy the things, okay? Everything has its pattern. So let's look at the pattern recognition. So in the early day about the pattern recognition, the first very important thing is what? Is how to extract the representative features. 怎么去做特征崛起？早期只谈这个事情。Now we have but now we have the deep learning. As I keep saying, because it's an end-to-end model. So the deep learning model can do feature extraction, and classification. Okay, at the same time. Okay, that's something good about the deep learning. Because in the traditional way, when you go for the feature extraction, somehow you need to be what? The domain expert. 你说你一定要是某个领域的专家，不然你没有办法决策。Otherwise, you don't know what to extract, right? As I just mentioned, you want to extract a feature for male or female. Everybody can understand that. But for some very specific manufacturing, for example, for semiconductor, okay, we want to identify the different types of defects. Then you need to have the knowledge about the semiconductor. You need to know something about the manufacturing process in semiconductor industry. Not everybody can think of how to describe the defect, right? But for the daily life, as I just mentioned, male, female, that you can understand is quite easy. But with the traditional way, you need some domain knowledge and design a good features. And then what? You need to know which features will be the most representative one for your application. Okay? That's because the traditional machine learning, this is the recognition error rate. Suppose this is number of features. Here's the shape. Which means when you increase the number of features, as I just mentioned, the hair, blah, 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 you can improve the accuracy or reduce the error rate But when you use too many features, then all the actual feature could be what? Could be noise. Then you will reduce your error rate. So in the early day, not just it's very important how to design the feature, how to extract the feature, and then it's very important how to select the right features. It's very tedious, very tiresome work. But now, if you go back to the deep learning, it's end-to-end. Now you can forget how to do the feature extraction work because you can leave the work to the deep learning. You only have to specify what do you expect from the what, which means you set up the optimization objective. And then you let your model to learn the feature automatically with the goal that will maximize your classification or maximize some of your tasks. That's the good thing about deep learning. But again, I need to mention, to train a good deep learning model, you need to collect a good training data set X, and also you need to manually label the expected output, okay, sample by sample or even pixel by pixel, especially for segmentation. Okay, so now if we go back to the traditional way, basically you don't need training sample at all, but you do need test sample to evaluate the performance of the feature that is extracted. But that's it, okay? But you need a lot of knowledge of the domain. But anyway, that's very important for the user. But for the next semester course, I will talk something about the high-level classifiers such as SVM, random forest, NFL, again different, but it will quite different from the one you learned in this semester because I will focus more on the time series data. They look the same, but the approach could be a little bit different. Okay, for me, I mean, time series data, especially for the collect data, you know, there's a technique called data augmentation. You can augment the data. You can augment the data so that you don't need to collect every possible image, right? But for this one, in the traditional image, it's quite easy to do the data augmentation because it can rotate. You can rotate the image. You can shift the image. You can scale the image, right? 你可以改变，你可以旋转，你可以位移，你可以尺寸。However, for time series data, it's very difficult for data augmentation because for time series data, you might have the data, right? There's no rotation, even not the shift. Basically, they are the same. I mean, it's more difficult. It looks, because time series data is a one-dimensional signal compared to the image, which is two-dimensional. But even for the one-dimensional time series signal, it's more difficult. Okay, for the viewpoint of data augmentation, so it has its own problem. Okay. ChatGPT, for example, basically is time series. Okay, because the text, you arrange the text in time series order, right? Okay. For video, you can conceive video as a combination of image and time series data. Video 它基本上就是影像加时序，所以它两个都有。Okay, so, but for this semester, I don't have the time to talk about the video. Okay, but if possible, I will talk about the traditional way to represent the motion, how to represent the motion. That's another way. We talk about the traditional machine vision so that we have a better representation and we input it to the deep learning model, for example, for the video. But actually we don't need to input the real-time series video. Instead of we transfer a video into some motion picture, okay? Then we can apply the deep learning to learn or to recognize the activity in a video. Okay, so basically the best idea, whatever you learn in this semester can be applied in different applications. Okay, but let me mention again, we will concentrate on the industrial application. Okay, but the basic idea will be the same. Okay, so that up to now you are supposed to know why I need to talk about the traditional machine vision. And then after the midterm, we'll skip to the deep learning. Okay, special. Let me go back to the traditional machine learning. Here's something you are going to learn. The very first is about thresholding. Okay, it could be your first assignment. Okay, very simple. Thresholding is to divide an image into a binary image. Let's say. Okay, so automatic, not manual. Okay, automatic. So let me assume we have an image. We have a 2D image. Okay. Let me take this steel ball again, okay? Now, we'll convert it into 1D, okay? Distribution, of value distribution. For this case, you might have something like this, okay? Or depends on the contrast of the object and the background. But we converted here. Here's our annotation. Okay, for the 2D image, we use XY to represent the location. Okay, XY is the location of some value. I will get into that. Okay. And then now I convert 2D into 1D distribution, which will be what? Which will be the value. Okay, is the value, and the y-axis will be the distribution or the probability that you can observe the intensity Z. Okay, then for this case, the thresholding is trying to, for this case, the best threshold appearing should be in the value, right? Here's the threshold. Okay, then I say if the value is larger than the threshold pretty, then I assign another image, a binary image, to be 1. Okay? Otherwise, then I let the image to be 0. Right? So after the transformation, what you got is a binary image. Right? So all the background will have the value of 0, and the object will have the value of 1. So just by counting the number of pixels with the value of 1, then you can count what? The area of the ball, right? So if you want to see, or even you can calculate the diameter of the ball. You can have a lot of geometric measure, okay, for the steel ball by convert the original 2D image into 1D distribution. So it could be very effective, okay, very effective. Why is that? If this image is 1K by 1K, the size is 1K 1000, okay? How many pixels you have here?
1 million.
1 million. Very good. 1 million. Okay. 1 or 2 million are the most the image resolution for your digital camera. Okay, so around 2 million. You can call it a big data. In your whole life, you might never have a chance to process the data set that contain more than 2 million data. But for this is how you to handle the image in manufacturing. And usually 1K by 1K is not enough to meet the manufacturing requirement. But anyway, if the value is only 0 to 255, why is that? I will say to you next hour. Now, originally you have 1 million data now converted into 1D. The data point becomes only 256. So we can reduce the data complexity from 1 million to only 256. So that the process time could be very, very fast. Right? Okay, especially in manufacturing. We use this technique a lot, especially what? If you want to measure the dimension, usually we take a backlighting. You know what I'm saying? The backlighting, you have the camera here, you have the object, here's the object here, this is the camera. Now the backlighting is we put the backlight here. Okay. For example, you put it on a glass, okay, a glass table. Then you do this over the backlighting because when you penetrate the glass, everything this will be bright, right? The light will be bright. So that will be what you got here. It's very close to a binary image. It is quite easy to separate the object from the background. And then, anyway, you can find a good threshold. That's the purpose for that. Okay. So again, in your material, I will say something about how to do the lighting, especially for manufacturing, but we don't have the time to mention. Okay, just for your own reference. We will focus on more on algorithm, how to develop the algorithm for the very specific application, especially for industrial application. Okay, let's take a break. Okay. We need the whole 3 hours today. Okay, so there's so much to talk about. Okay, so next hour I might give you some background information about what is camera, what is pixels, okay, and how we handle the pixel. Okay, and starting from next week, I will start from the traditional algorithm, especially from thresholding. Okay, let's take a break.